Welcome to the Deep Dive. Today we're tackling a really crucial topic in the fast-moving world of artificial intelligence, AI benchmarks.
Mm,
It feels like every single day there's a new headline, some incredible leap in what these large language models or image generators can do.
it's nonstop.
Yeah, and it can be tough to really get a handle on who's, leading the pack and where exactly. It's a real whirlwind.
It is, definitely. And that's precisely why understanding benchmarks is so vital, really.
Right.
Think of them as the essential yardsticks, the tools we use to get a clear, sort of objective measurement of what these AI systems can actually do, their capability.
Exactly. So whether you're, actively working with AI or just really curious about its potential, grasping what these benchmarks tell us is key. They
Absolutely.
give us a way to actually assess things like, okay, how accurate is this AI? How fast does it run?
Uh-huh.
What about its reasoning? How well does it handle complex context, remember things, even image generation skills?
And interestingly, even how well they perform in specific jobs,
Right.
right? Like medicine or law.
Yeah, those sector-specific ones. We'll get to those. And what's fascinating is how these benchmarks themselves are like constantly evolving too.
Oh, completely. They have to. They're not static. They're always being refined, expanded, to keep up with the AI progress and test new things.
And that's exactly what we're going to explore in this deep dive. Our mission today is to really demystify AI benchmarks.
all good.
We'll look at where they came from, how they've developed, and how they're used right now across all sorts of different AI models.
Right.
We'll cover accuracy and reasoning, speed and efficiency, then context window and memory, image generation, and finally those sector-specific tests.
Covering all the bases.
Okay, let's dive right in. First up,
Wow.
accuracy and reasoning benchmarks. Seems pretty fundamental, right?
Mm.
Why is it so important to really test an AI's ability to, well, think?
Well, if you think about it, an AI's cognitive skill, its logical deduction, that's what makes it valuable for actual real-world problems. We need to trust it, right? Trust that it can make reliable judgments, understand complex stuff, and that's where benchmarks like MMLU come in.
MMLU, massive multitask language
Yeah.
understanding. Got it. So this one tests general knowledge across lots of academic subjects.
Yeah, exactly. Think of it like testing if the AI could pass finals in history, computer science, you name it.
And OpenAI's GPT-4 has done really well on this one, historically.
That's right. GPT-4 showed really impressive general knowledge, strong reasoning across all those different areas. And what's interesting is seeing how the newer one, GPT-4o, builds on that. It adds these enhanced, like real-time multimodal capabilities.
So not just text anymore. Vision, audio.
Exactly, processing and integrating all of it. And even their much earlier model, GPT 0.1, showed surprisingly strong baseline reasoning when they scaled it up.
Wow, that really shows the power of scale, doesn't it? Okay, and then there's MMMU, massive multidiscipline, multimodal understanding. Sounds even more complex.
It is, yeah. MMMU goes beyond just language. It tests reasoning with text, but also images, diagrams, tables.
All mixed together.
Right, within academic subjects like physics or biology. It's really pushing towards, true comprehension, synthesizing different kinds of information.
Okay, so we're seeing benchmarks getting more and more sophisticated.
Yeah.
What about Big Bench? That sounds more like a community effort.
It is, yeah. Big Bench is pretty cool because it's collaborative. Researchers contribute all sorts of diverse tasks.
Okay.
It probes a really wide range of AI skills, language, reasoning, complex problem solving. Anthropic's Claude 3 Opus did very well on Big Bench, showing off its nuanced understanding.
And Claude has a newer version now too, right? Claude 3.7.
Claude 3.7, released back in March, it seems to be even better at reasoning, especially with context.
Yeah.
And importantly, it's getting top results now on things like the ARC challenge, that's advanced reasoning, and also MMLU. Plus, there's a big focus on safety and alignment.
That safety alignment piece feels absolutely critical as these things get more powerful. Now, you also mentioned truthful QA earlier. What's that one about?
Truthful QA tackles, well, the truthfulness problem, potential misinformation.
Right.
It specifically checks if a model gives truthful answers, which is obviously vital for real-world use. You don't want your AI giving bad medical advice or financial tips.
Absolutely not.
Yeah.
Okay, and Google DeepMind, they're obviously a huge player with Gemini. How do their models perform on these reasoning tests?
Right, Gemini. So Gemini 1.5 showed strong MMLU results. And the latest, Gemini 2.5, has made big strides in coding, logical reasoning, and multilingual understanding.
So really competing head-to-head now.
Definitely positioning itself as a strong rival to the latest from Anthropic and OpenAI on these core cognitive tasks.
It's such a fast-moving space. And Mistral's Mixtral model has also been impressive, hasn't it?
Mistral's interesting because it's, well, more efficient, a smaller architecture, but it still performs really competitively on synthetic reasoning and coding tasks. That efficiency is a big plus for, running AI on less powerful hardware or locally.
Makes sense. And then there's xAI's Grok 1.5.
Yeah, Grok 1.5 is getting noticed for performing well when it needs to adapt to real-time context, understanding information as it comes in.
That real-time adaptation sounds super useful for things like chatbots or dynamic searches. And DeepSeek's R1, they've been making waves too.
Exactly. DeepSeek R1 is built for efficient, large-scale reasoning. It's done well in few shot, learning new things from just a couple of examples.
Oh, interesting.
And it's also showing strong results on newer, tougher benchmarks like Arena Hard and GPQA, which really push complex reasoning.
So it really feels like each of these top models has its own strengths, doesn't it? GPT-4o with multimodality, Claude 3.7 focusing on nuance and safety, Gemini 2.5 recoding.
It really highlights the different priorities, the different paths these research teams are taking. It's not one size fits all.
Okay, let's shift gears a bit. We've talked about how well they think, but how fast and efficiently they work is often just as vital, right? Speed and efficiency benchmarks.
Precisely. For so many applications, speed and efficiency are just as critical as accuracy, especially if you have hardware constraints or need real-time responses. This is where MLPerf comes in.
MLPerf from ML Commons. What does this benchmark actually measure?
MLPerf is all about standardized metrics for speed and energy efficiency across different AI tasks.
Okay.
A big focus is on the hardware performance during inference. That's when the AI is actually doing its job, making predictions on new data.
And when we talk hardware, NVIDIA's H100 chips always seem to come up.
They do. They consistently top the MLPerf charts. These H100 GPUs, based on the Hopper architecture, are just built for the heavy lifting of modern AI.
How so?
They have huge memory bandwidth, special hardware units for accelerating transformers, the basis of many LLMs, and just massive parallel processing power.
So ideal for giants like GPT-4 and Gemini.
Exactly. Where speed and the ability to scale up are crucial, their strong showing in MLPerf has really made the H100 the industry standard for high-performance AI hardware.
So MLPerf gives us insight into both the model and the hardware powering it. Okay. Now, another critical piece. How well these models remember things over long conversations or long documents, context window, and memory. Why is this so important?
Well, think about it. If you're having a long chat with an AI or asking it to summarize a huge report,
Right.
it needs to remember what was said or written earlier. Context window and memory benchmarks test exactly that. How much info can it hold and use effectively?
And we have specific tests for this, like swim and mile bench.
Exactly. Swim Snorkel Working Memory Test focuses on handling really long text sequences. Does it maintain coherence? Can it use details from way back?
Okay.
MileBench pushes it further into multimodal long context scenarios. So handling long inputs with text and images or other data over time.
Now, we've seen some claims about massive context windows, Meta's Llama 4, for instance.
Yes, the Llama 4 models, like Scout and Performance, claimed context windows up to like 10 million tokens, which sounds staggering.
It does.
But the initial results they shared faced some scrutiny. They were mostly internally validated, leading to debates about transparency and how exactly they tested it.
Okay, so just having a big window isn't the whole story.
Not necessarily. It raised important questions about fair, rigorous standards for evaluating these long context abilities.
Makes sense. A model might ingest a lot of text, but can it actually use it effectively?
Mm-hmm.
What about Claude and GPT-4o here?
Well, Anthropic's Claude 3.7, its window is up to 200,000 tokens, but it shows really good consistency in remembering things and reasoning contextually, especially in back-and-forth chats.
Okay.
And OpenAI's GPT-4o, supporting 128,000 tokens, really excels at integrating different inputs, text, audio, vision within that context window.
So it's really becoming clear it's not just the raw token count, but how well the model uses that context.
Precisely. On benchmarks like Swim and MileBench, GPT-4o and Claude 3.7 often perform better in terms of interpretation and coherence than Llama 4, even with its theoretically larger window.
Right.
It really underlines that the underlying architecture and, frankly, transparent benchmarking matter just as much, if not more, than just the token limit number.
That's a really crucial point for anyone trying to evaluate these things.
Yeah.
Okay, let's switch to the visual side, image generation. How do we benchmark those skills?
Yeah, with text-to-image models getting so good and multimodal models becoming common, we need ways to test their visual intelligence.
Their ability to understand and create images based on prompts and reason about visual stuff.
Exactly, and we have benchmarks like Mementos for that.
Mementos.
It specifically tests how multimodal LLMs reason over sequences of images, like understanding how something changes visually over time.
Interesting. And MLPerf covers image generation too.
It does. MLPerf has specific tasks for text-to-image generation, so we can evaluate models like Stability AI's Stable Diffusion XL on speed and the quality of the images they produce.
And we've seen some pretty amazing progress here recently. How are the big models stacking up?
Well, Stability AI's Stable Diffusion 3 benchmarked with MLPerf shows big gains in detail and rendering speed compared to older versions.
Okay.
OpenAI's DLE3, especially integrated with GPT-4o for real-time use, is very seamless from prompt to image.
And Midjourney.
Midjourney V6 is still often seen as the leader for pure aesthetic quality, that artistic flair, though being proprietary makes direct benchmarking a bit tricky.
Right. It's harder to compare apples to apples.
And Google DeepMind's Imagen 2.5 is making strides in compositional logic, getting objects placed correctly and realism, especially for specialized things like scientific illustrations.
So this sounds like each has its own kind of artistic niche almost.
Kind of, yeah. Stable Diffusion 3 is great for its open-source adaptability, Midjourney V6 for artistry, DALE3 for following prompts closely and speed, Imagen 2.5 for realism in specific fields.
And benchmarks help quantify these differences.
Exactly. Tests like 01T2I, which looks at creating new views of objects, and Mementos for visual reasoning help us understand these different strengths more objectively.
This is all super helpful. Now, let's move to something really practical. Sector-specific AI benchmarks. Why are these becoming so important?
Oh, they're absolutely crucial because they test how well AI performs on the very specific, often tricky requirements of different professional fields.
So beyond just general knowledge.
Way beyond. General benchmarks give you an overview, but these domain-specific tests show if an AI is actually ready for reliable use in medicine, law, finance, places where mistakes are costly and context is everything.
So instead of history question, it's asking about, say, medical diagnosis.
Exactly. Take medicine, you have MedQA. It uses questions derived from the U.S. medical licensing exam, the USMLE. A high score there suggests real potential for helping doctors. Then there's PubMedQA, which tests understanding of biomedical research papers from PubMed abstracts.
Okay.
And BioASQ measures things like biomedical semantic indexing and question-answering key for navigating complex biological info.
That level of detail is vital for trust in sensitive areas like healthcare. What about law? Similar specialized tests.
Yeah. For law, there's CaseHold. It gives hypothetical legal situations and asks the AI to predict court decisions. Useful for legal research, maybe even forecasting outcomes.
Interesting.
And Legal Bench is broader. It tests statutory interpretation, comparing cases, analyzing contracts, core lawyerly tasks.
And finance must have its own set, too, with all its regulations and data.
Absolutely. VQ targets financial sentiment analysis, understanding opinions in financial news, and Q&A on financial topics. Really useful for fintech, market prediction.
Makes sense.
There's also LIFE, that's legal, investment, financial, economic, a broader benchmark covering regulatory compliance, economic modeling, financial analysis, critical stuff for decision support.
It's amazing how tailored these are. What about education or language learning?
Yes, definitely. There's ARC, the AI2 Reasoning Challenge. It tests science comprehension, like at elementary and middle school levels, focusing on reasoning, not just facts. And Helliswag and PIQA test common sense reasoning and understanding everyday procedures. Things you'd need for, say, an adaptive learning system or a tutor bot.
So how are the top models we discussed earlier doing on these specific tests? Any patterns emerging?
It's really interesting. GPT-4o and Claude 3.7 both perform well on medical benchmarks like MedQA and BioASQ.
Okay.
Some analyses suggest Claude's alignment training might lead it to be a bit more cautious, maybe more accurate in medical contexts.
That makes sense.
DeepSeek R1 has shown competitive scores in life and casehold, maybe reflecting a focus on regulated industries.
Yeah.
And Gemini 2.5 looks strong on FIQ tasks, especially things like economic forecasting based on context.
It really drives home the point, doesn't it? Doing well on general knowledge doesn't automatically mean top performance in these specialized areas.
Not at all. You need that specific domain knowledge and the ability to apply it correctly in that context. It's nuanced.
Well, this has been an incredibly insightful deep dive into AI benchmarks. It's so clear that understanding these evaluations is, well, essential for anyone choosing AI tools for specific jobs or tasks.
That's absolutely right. These benchmarks give us those crucial standardized metrics, to make informed comparisons across all these different models and their various skills, reasoning, speed, memory, specialized knowledge.
Mm-hmm. And as AI keeps evolving so fast, staying informed about how we evaluate it is just going to be more and more critical for making smart decisions professionally and academically.
And that actually raises a really interesting point for everyone listening. Now that you have this grounding in AI benchmarks, what specific AI applications are you most curious about exploring next?
Yeah, that's a great question.
Maybe digging into the specifics of certain benchmark data sets or even, trying out some hands-on evaluations of AI models yourself could be a really cool next step.
Absolutely. And on that note, we just want to mention that this kind of deep dive, this exploration of understanding AI benchmarks, is really representative of the sort of thoroughly researched, structured, yet practical microlearning we focus on.
Mm-hmm.
So if you're looking to really deepen your understanding of applied AI, from the core ideas to how it's used in practice, much like we discussed today, we really encourage you to check out the resources at University 365.
Right.
Our concepts, our courses, our whole teaching approach, it's all designed to give you that comprehensive knowledge and those practical skills needed in this vital, fast-changing field.